Oh, your first definite integral. I'm so excited. My students, they're growing up. I'm going to start with a function x squared. This dude is a really simple function. I picked him because of what we can do with him. F prime of this function would be 2x. Okay, so just tuck that in the back of your head. And I'm going to write your first ever definite integral. Look at that dude. Okay, I know the first thing we did is we took indefinite integrals. And these numbers right here were not here. And so now I'm going to show you guys what the heck these numbers mean. All right, so I'm going to do that by drawing a graph. Okay, first I'm going to graph this function. Oh, and let me pause for a second. You see this right here? It means a number of different things. And we're going to talk about those meanings, but right now I'm only going to talk about the geometry of it, the geometry meaning of an integral. Okay, so we've already looked at Riemann sums, where we can estimate the area under the curve, where we draw rectangles. We also drew trapezoids underneath the curve so that we can estimate the area under the curve. Here, we're going to be able to find the exact area under the curve. And this isn't always true. It really depends on your function. Now, this function is a linear function, so it makes it so that you can find an exact area. So let me show you guys really quick. I'm graphing it right here. This is a linear function. The y-intercept would be 0 because there's no constant adding or subtracting from it. So I put the y-intercept right there. My slope is whatever's multiplying the x, so it's 2 over 1. So I go up 2, right 1, up 2, right 1, and there's my function. So this is 2x. What does this 0 and this 3 mean? It means that's our interval that we care about. So we want to find the area underneath this curve, underneath this f prime, underneath this 2x, from 0 to 3. So I'm going to go ahead and draw a line right here, a boundary there, and then I'm going to shade this in. This is the area that I'm looking for. So if you're trying to find this, all you have to do is find the area of this triangle. That's it. So we have the area of a triangle equals 1/2 base times height. So we have 1/2. The base on this one is 3. I'm going to make this my base for this triangle. The base and the height have to be perpendicular for triangles. I don't know if you guys remember that. So it's 3. And then the height, I'm going to have to take the 3 and plug it into this. Or you can count it, obviously. But 3 times 2 is going to be 6. So my height is 6. So I put in 6 right there. 1/2 of 6 is 3. Then we have 3 times 3 will give us 9. So this integral equals 9. Now, I'm able to be exact with this one. Sometimes you're not able to be exact. If you have something like this, what is it? Let's square root of x, all right? Square root of x is not a linear function, so it's going to be curvy. It's going to look like this, all right? To find the area underneath this curve from 0 to 3, we're going to have to use estimation because we're curved here. There's no formula. I mean, this is a Funkadunka shape. Look at this. There's no formula to do that. So we're going to have to estimate. Use left-hand Riemann sums, right-hand Riemann sums, midpoint Riemann sums, or random Riemann sums, or trapezoidal sums. Actually, I probably would use trapezoidal sums on this one. And I would break it up into 3 categories. Point, point, there's a trapezoid right there. And then I would go another one, and then another one right there. So I would find the trapezoid area for each of these. Actually, this one, yeah, you could still do it with this one. And then that would be an estimate. So your answer for this one would be an estimate. It wouldn't be exact. But anyways, that is, those are definite integrals in the geometry perspective.